Hey everybody, today we're in section 2.4 of college algebra talking about linear functions, and some of the things we're going to talk about today are slope. We're going to talk about how to graph linear functions. I'm going to show you the slope-intercept form of the line, and we will also look at the standard form of the line and exactly what that means. So let's jump right into it. So what do we mean by linear function? Well, a function f is a linear function if it can be written f of x equals ax plus b for real numbers a and b. In other words, we can have an x term and a constant, but that's all. Now, either a or b can equal 0, but there can't be any powers of x other than the first power. So if a equals 0, you won't have an x term, you'll just have a constant. And if b equals 0, you won't have a constant, you'll just have an x term. So you can have one or the other or both, but no other powers of x. The graph of a linear function is always a straight line. That's why it's called a linear function. And here are a few examples of linear functions. So y equals 2/3 x minus 7 is a linear function because remember, f of x and y are interchangeable. We learned that when we talked about function notation in a previous section. And so in this case, the a number is 2/3 and the b number is -7. So this is a linear function. 3x minus 6y equals 20 is a linear function because even though it's not solved for y, you could solve it for y, and then what you would have would be an x term and a constant. F of x equals 4 is an example of a linear function where the x term is 0, the coefficient of x is 0, and all we have is a constant. So this would graph a straight line. In fact, it would be a horizontal line. And then y equals -8x is a linear function, and this is an example of a linear function where there's no constant term. So we just have the x term. And here are a few functions that are not linear. So if we had f of x equals 2 over x plus 5, the graph of this would not be a straight line because in this case x is in the denominator. So this graph would draw something else. And f of x equals 3x squared minus 4 would not be a linear function because of the x squared. And y equals square root of x plus 2 would not be a linear function because we don't have just x to the first power, we have this square root of x. Okay, now let's talk about slope. Slope is just a measure of the steepness of the line. So the slope tells us about the steepness and the orientation. And what I mean by orientation is it tells us whether the line is sloping uphill as we go from left to right or downhill as we go from left to right, or maybe it's a flat horizontal line or a vertical line. So the slope tells us the steepness and the orientation. Now, because a straight line does not bend, the slope of the line is the same everywhere on the line. So if we were to measure the slope between this point and this point, it would be the same as if we measured the slope between here and here. So it doesn't matter which 2 points you use, the slope will be the same everywhere on the line. Now, slope is usually represented by the letter m, and fun fact for today, the reason it's represented by the letter m is because the mathematician who came up with the idea was French, and the French word for slope starts with m. So how about that? And so the letter m got attached to the idea of slope, and it even carried over into English. And now we're going to go ahead and get the formula. So in order to use the slope formula, we need to know 2 points on the line. The first point we'll call x1, y1, and the ones just indicate that this is the first point we're talking about, and the second point we'll call x2, y2. So to calculate slope, we say m equals the difference between the y coordinates, so it's usually written as y2 minus y1, divided by the difference between the x coordinates, so that's written x2 minus x1. So slope equals y2 minus y1 over x2 minus x1. We can always think of slope as rise over run, and that's very helpful to remember that because that will help you remember that the y values go in the top. See, the difference between the y values shows you how far the line rises from one point to another. So rise over run. Now there's one thing we need to be careful about here. When we're using the slope formula, it does not make any difference which point you call x1, y1 or x2, y2, but you must be consistent. Start with the x and y values of either point and then subtract the corresponding value for the other point. So you could have y2 minus y1 over x2 minus x1. That's the way we usually see the formula written. But since the 1's and 2's are interchangeable, you could also have y1 minus y2 over x1 minus x2. See, that's not going to change the answer. It's still going to give you the same slope. But what you can't do is you can't mix them up. If you start with the y coordinate for the second point, then in the denominator you need to start with the x coordinate for the second point. You can't have y2 minus y1 over x1 minus x2, and you can't mix them up the other way either. So if you start with the y value from the second point, you need to start with the x value from the second point. And that's just something to keep in mind. That's an easy thing for students to mix up. And the other thing to keep in mind, again, is that you always want to make sure you have y values in the top and x values in the bottom. And if you'll remember rise over run, I don't think that will be a problem for you. Now here is example 1, and we're going to look at several examples where we practice using the slope formula, and I'm going to point out a few different things to you as we go along. So notice that the instructions say find the slope of the line through the given points. In part A, the given points are -4, 8 and 2, -3. Now we can absolutely use the formula to find the slope of the line between these 2 points without graphing the points, but I think it's helpful to you to see the points graphed, so we're going to do that. -4, 8 will be left 4 and up 8, so we'll have a point here. And then 2, -3 will be right 2 and down 3, so we'll have a point here. And here is the line between them. Now notice this line is sloping downhill as we go from left to right. Anytime we talk about uphill or downhill, we'll always be thinking about going from left to right, the same direction that we read. So now let's go ahead and use our formula. So we're going to label our points x1, y1, and x2, y2. So I labeled these 1 because they are the first point, and I labeled these 2's because they are from the second point. So x1, y1, x2, y2. And we know the formula is y2 minus y1 over x2 minus x1. So now plugging in the values, that's going to be -3 minus 8. And in the bottom, that's going to be 2 minus -4. Okay, now we'll evaluate. So in the top, -3 minus 8 is, we know that's -3 plus -8, so that's -11. And in the bottom, 2 minus -4 is the same as 2 plus 4, so that's 6. And so the slope of this line is -11 over 6. Now, notice that this fraction came out improper, and that is totally fine. We will never convert an improper slope into mixed number form because we always want to be able to think of the slope as rise over run, and it's hard to do that when the number is in mixed form. So we always leave our fractions in pure fraction form. All right, now the other thing I want you to notice is that because this line is sloping downhill as we go from left to right, this slope came out negative. So I want you to link those in your mind. Whenever the slope is negative, the line will be going downhill as we travel from left to right. Now here's part B, and so we've got -2, -5, and 3, 4. And again, we'll plot these points. So -2, -5 will be here, and 3, 4 will be here. And the line between them looks like that. And so now let's label our coordinates. So this is the first point, so these two numbers will be x1, y1, and then these two numbers will be x2, y2. Now our formula again, y2 minus y1 over x2 minus x1, and plugging in values, that's going to give us 4 minus -5 over 3 minus -2. Okay, now evaluating, 4 minus -5 is 4 plus 5, so that's 9. And in the denominator, 3 minus negative 2 is 3 plus 2, so that's 5. Again, this is improper, which is fine. Just leave it as 9 over 5. And this time, notice that because we have a line sloping uphill to the right, our slope came out positive. So when the line slopes uphill to the right, then as you go from one point to another, a positive rise and a positive run give you a positive slope. So that's why this slope comes out positive. Now part C. Here we have 2, 7 and 2, negative 4. So we'll plot those 2 points, and you can see that the line they give us is a vertical line. Well, let's see what happens to the formula. So we're going to label our coordinates again, and then our formula is y2 minus y1 over x2 minus x1. So that's going to be negative 4 minus 7 over 2 minus 2. In the top, negative 4 minus 7 is negative 11. In the bottom, 2 minus 2 is 0. Well, this says negative 11 divided by 0, and we know that it's not possible to divide by 0, so this does not even represent a number. We call this undefined. This number is not possible. So a vertical line will always give you an undefined slope because it has no run. The result in the bottom of the formula will always be 0, and so the slope will always come out undefined. And here's part D. So we have 5, negative 3 and negative 2, negative 3. Those 2 points are here and here, and so you can see that that gives us a horizontal line. When we plug into the formula, we have in the top negative 3 minus negative 3, and in the denominator negative 2 minus 5. So the top is going to be negative 3 plus 3, that's 0, and the bottom is going to be negative 2 minus 5, that's negative 7. Now it doesn't matter what the denominator is. If the top is 0, that's 0. 0 divided by anything is still 0. And so you can see that for a horizontal line, the slope will always come out 0 because a horizontal line has no rise, and therefore the result of the top of the formula will always be 0. So let's kind of summarize what we just saw in the previous example. A line with a positive slope rises from left to right, so it goes uphill from left to right. A line with a negative slope falls as you go from left to right. A line with a slope equal to 0 is going to be horizontal, and the slope of a vertical line is undefined because it has no run. Now we've got this little practice problem that I want to look at with you. So it says for each given slope, identify the line in A through F that could have this slope. So we have 6 different graphs here, and notice there are no numbers, so we really can't calculate the slopes, but we're just going to use what we know about the orientation of the line to help us eliminate some of the choices. So first of all, I noticed that graph A is a completely horizontal line, and I know that horizontal lines always have a slope of 0. So I'm going to go ahead and match up graph A with the slope m equals 0. And then I notice that graph B is a completely vertical line. So I know that vertical lines always have an undefined slope, so I'm going to go ahead and match up graph B with a slope of undefined. Now for graph C, I know that this is a line with a negative slope, but I also see that choice F is another line with a negative slope. Now, I don't have any way to calculate the slopes because I don't have any tick marks, but I do see that this line is slanting downhill faster than choice F. So I know that this is a more negative number, or in other words, a larger negative number than choice F. So I'm going to look over here for my negative slopes, and my choices are that I have a slope of negative 3 and a slope of negative 1/3. So since C is the steeper line and it's got a negative slope, I'm going to say that m equals negative 3 matches graph C, and m equals negative 1/3 matches graph F. And that leaves us with choice D and choice E. So both of these are positive. Choice D is not as steep as choice E. So that tells me that if my two choices for the positive slopes are 1/3 and 3, then choice D is going to have to be the smaller of the two numbers because it's not as steep. So choice D is going to match with a slope of 1/3, and choice E is going to match with a slope of +3. Now let's talk about how to use the slope to graph a line. So you can always graph the line if you know the slope of the line and any point on the line. What you do is you plot the known point, and then you don't even have to calculate the next point. All you do is use the slope as rise over run to count to the next point and plot that, and then you'll just connect the two dots with a straight line. So here is an example for us to practice on. This says graph the line passing through the point -1, 5 and having slope m equals -5/3. So the first thing we do is we plot the point -1, 5. So that point will be left 1 from the origin and up 5. So our point goes there. And then we want to use the slope as rise over run. So you may be asking yourself, how do I know whether the top number should be negative or the bottom number, or maybe they both should be negative? Well, we know that slope is rise over run. So what you want to do is attach the negative to either number. I like to attach the negative to the top. You cannot attach the negative to both top and bottom, because if both numbers were negative, you know negative divided by negative is positive. And so they can't both be negative if the fraction is negative. But either one of the numbers can be considered negative. I like to consider the top number negative. And so if we think of slope as rise over run, we'll have a rise of -5 and a run of +3. So from here, I'm going to go down 5, 1, 2, 3, 4, 5, and right 3, 1, 2, 3, and this is where my second point will go. And then I connect the two dots with a straight line. And so that's how that works. Notice again that because we have a negative slope, we have a line that is slanting downhill as we go from left to right. Now here is a similar example for you to practice with. I want to encourage you to stop the video here and try this on your own before you watch me do it. Okay, so here I go. Graph the line passing through the point 3, -4 and having slope m equals 3/2. So of course the first thing we do is plot our point 3, -4. So from the origin we go right 3 and down 4. There's our point. Now we use slope as rise over run. So it says rise over run is 3/2. That means from this point we rise 3, 1, 2, 3, and we run 2, 1, 2. That's where our second point goes. And now we just draw a straight line between those 2 points. And again, notice that this line is slanting uphill as we go from left to right, and it has a positive slope. So now let's talk about the slope-intercept form of a line. Sometimes you need to know the slope of a line just by looking at its equation, and you don't have a graph where you can get points and use the slope formula. Well, if you have the equation of a line, you don't have to use the slope formula to know the slope of that line. All you have to do is solve for y. When the equation is solved for y, it will tell you the slope. Okay, so when the line is in the form y equals ax plus b, the slope is the coefficient of the x term, and the y-intercept is 0, b, whatever that b number is, that's part of the y-intercept. Okay, so again, the coefficient of the x term is your slope, and the b number is the y-coordinate from the y-intercept. And because you can look at the equation in this form and see the slope and see the y-intercept, this form is called slope-intercept form. But we said earlier that slope is usually represented by the letter m, and so we usually see this written as y equals mx plus b instead of y equals ax plus b. But whether it's an a or an m, it doesn't matter. Whatever number is sitting in that slot, that number is the slope, the other number is the y-intercept. So in this example, we're just going to practice looking at the equation and getting the slope and the y-intercept from that equation. Now, here in part A, we have y equals 1/2 x minus 7. When the equation is already solved for y, the numbers that you see are the slope and the y-intercept. So in this case, the slope is 1/2, so m equals 1/2, and the y-intercept is going to be 0, negative 7. So remember that the y-intercept is a point, so it's going to have an x-coordinate and a y-coordinate. The x-coordinate, of course, is 0, and that's because the point is on the y-axis. But this number right here is the y-coordinate of the y-intercept. So 0, negative 7 for this one. Now in part B, this equation is not solved for y. So in this case, we can't see the slope and the y-intercept right away. We have to rearrange the equation so that the y is isolated. So that's going to involve getting rid of this x term and then getting rid of this coefficient. So first we want to isolate the y term. So we'll subtract 4x from both sides, and that will give us 3y equals negative 4x plus 12. Now, if you are comfortable not writing this and you just want to move the x term to the other side and know that the sign will become negative, then that's fine too. I want you to get comfortable doing that, but I didn't want to lose anybody. So I've subtracted 4x from both sides, and that effectively makes it look like the x term moves to the right side and changes sign. Okay, now I need to get rid of this coefficient. So I divide the left side by 3. That means I have to divide everything on the right side by 3. And these 3's will cancel out, leaving us y equals negative 4/3 x. See, that can't be simplified, so it just stays negative 4/3. And then plus 4, because 12 divided by 3 is 4. So whenever you can simplify, you should. But if you can't simplify, then you just can't. But now that this equation is solved for y, we can see that the slope of this line is going to be negative 4/3. So m equals negative 4/3. And the y-intercept is 0, 4. Because this number always represents the y-coordinate of the y-intercept. Okay, part C, here we have 2/5 x minus y equals 3. And again, I've got to isolate the y, and I want to make sure that it's positive before I can see the slope and the y-intercept. So I'm going to start by moving the x term to the right side. Of course, that's going to make it become negative. And now I need this coefficient to be positive 1, not negative 1. So what I'm going to do is multiply both sides by negative 1. And negative 1 times negative y is positive y. And then if I distribute this negative 1, it will just change both of the signs. So negative 2/5 x will become positive 2/5 x. And plus 3 will become minus 3. And so now we can see that the slope of this line is going to be 2/5. And the y-intercept of this line is going to be 0, negative 3. And now we're going to practice graphing a line that's in slope-intercept form. This is exactly the same procedure that we did a few problems back when we were given a point and a slope. It's the same procedure, it's just that now the point that we know will always be the y-intercept. So this is the easiest way to graph a line because it doesn't require any calculating or any formulas or anything. If you've got the line in slope-intercept form, you're going to plot the y-intercept and then use the slope as rise over run to get to the next point and connect the 2 points with a straight line. Now, before we do a couple of examples together, on these questions in my lab, they will frequently ask you, what is the domain of this line? What is the range of this line? So remember that the domain is the set of all x values that a function can have, and the range is the set of all y values that the function can have. For all lines except horizontal and vertical lines, the domain and the range will both be negative infinity to positive infinity, and we'll see why in just a minute. And we'll also look at a couple of examples with horizontal and vertical lines so you can know what happens to the domain and range on problems like that. Okay, example 4. Graph f of x equals 2/3 x minus 6. State the function's domain and range. Okay, Well, we can look at this equation and know that the slope of this line is going to be 2/3, and the y-intercept of this line is going to be 0, -6. So once we have that information, it's easy to graph. We start by plotting the y-intercept, so that's going to be at -6 on the y-axis, and then we use the slope as rise over run to get to the next point. So from here, rise 2, 1, 2, and run 3, 1, 2, 3. This is where our second point goes. Connect the 2 points with a straight line, and there's your line. Now, you can see that this line extends indefinitely to the left and indefinitely to the right. So the domain of this line is -infinity to +infinity. The range is the lowest y value to the highest y value. So you can see that the line extends forever downward and it extends forever upward. So the range is going to be -infinity to +infinity. And let's look at another one. So it says graph f of x equals -2x plus 4. And we know from looking at this equation that the slope will be -2. Now we want to think of the slope as a fraction, and so a fraction needs a denominator, and so -2 we will think of as -2 over 1. And then the y-intercept is going to be 0, 4. Okay, so now let's plot our y-intercept. That will be at 4 on the y-axis, so 0, 4. And then the slope is rise over run. So we will rise -2. In other words, from here go down 2. And then run 1, so +1, so that'll put us right here. And we connect those 2 dots with a straight line. And again, you can see why every time you have a line that's not a horizontal or vertical line, the domain is always going to be -infinity to +infinity because the line extends forever to the left and forever to the right. And the range is always going to be -infinity to +infinity because the line extends forever downward and forever upward. Okay, here's one that does not have a constant term. So this one just says f of x equals 3/4 x. Well, if we had to have a constant term to know where the y-intercept was, that constant term would have to be 0 because there's nothing there. So now that you see it written this way, you can know that the slope of this line is going to be 3/4, and the y-intercept is going to be 0, 0. Okay, so we'll put a dot at the origin for the y-intercept, and then we'll use slope as rise over run. So from here, up 3, right 4, and then put a dot and connect the 2 dots like that, and so there's your line. Now the domain, as always, is -infinity to +infinity, and range, same thing. Now here is an equation that's not in slope-intercept form because it's not solved for y. So before we graph it, we'll have to put it in slope-intercept form, and we'll also state the function's domain and range here. So the only thing I have to do here to get this solved for y is divide both sides by 3. So we'll do that. Divide the left side by 3 and divide everything on the right side by 3. And that gives us y equals -5/3 x plus 6 divided by 3, which is 2. And so now we know that the slope of this line is -5/3, and the y-intercept of this line is going to be 0, 2. We start by plotting the y-intercept, so we put a dot at 0, 2 on the y-axis, and then the slope is -5/3. So thinking about rise over run, from here we go down 5 and right 3 and put our dot and connect the 2 dots. And that's it. Domain and range, -infinity to +infinity, as usual. Now let's talk for a minute about horizontal lines. So in a horizontal line, you can see that every point on the line is going to have the same y value. They all have the same height. That's what keeps the line flat. So they all have the same y coordinate. A horizontal line that passes through the point A, B, whatever those numbers are, will have the form f of x equals b, or you might see it written as y equals b, because we know that f of x and y are interchangeable notation. So the equation of a horizontal line will look like y equals some number. Okay, sometimes this is called a constant function because the y value always remains the same no matter what the x value is that you're plugging into it. And since a horizontal line has no rise, as we've already seen, the slope is 0. We knew that from before. Okay, now for a vertical line, every point on the line has the same x value. If you have a completely vertical line that's going straight up and down, every point on that line will have the same x value. A vertical line that passes through the point A, comma B will have the form x equals A because all of the x coordinates are the same. Now, vertical lines are not functions because they do not pass the vertical line test, and as we've seen before, the slope of a vertical line is undefined because a vertical line has no run. In other words, the slope formula would give you 0 in the denominator. We've seen all that before. Okay, so here's example 5. It says graph f of x equals -3. And so we know that that is the same as saying y equals -3. And so this tells us that every point on this line is going to have a y coordinate of -3. So just plot any point that has a y coordinate of -3. So like this point has a y coordinate of -3. So does this point. Any point on this level will have a y coordinate of -3. So if you just plot a few of them, you can see that this is going to form a horizontal line. And now let's talk about the domain. So the domain of this line is still -infinity to +infinity because the x values extend forever to the left and forever to the right. So that hasn't changed. But the range is no longer -infinity to +infinity because this line only has one y value, and that y value is -3. This line does not extend forever upward and forever downward. This line only has one y value, so we won't have an interval like we did for the domain. We have just one value, and since it is just one value, we put it in curly braces like it's a set. We consider it a set that only contains one number, and that number is -3 because every y value of every point on this line is -3, and so the range is just that one number. Now let's graph x equals -3, and we'll state the domain and range. So notice the difference. Before we had f of x equals -3. That was the equivalent of saying y equals -3. But here we have x equals -3. So this is not going to be a function. This is going to be a vertical line where every x value is -3. So if we just plot a few points where the x value is -3, you could see like that one would work, this one would work, this point has an x value of -3, this one has an x value of -3. Any point that has an x value of -3 is going to be part of this line. And so we get a vertical line out of that. Now this time the domain has changed because this line does not extend forever to the left and forever to the right. This line only has one x value, and that x value happens to be -3. So the domain is just the set containing -3. It's -3 in curly braces. And the range of this line is -infinity to +infinity and every number in between, because this line extends forever downward and forever upward. So the y values are all the numbers between -infinity and +infinity. Okay, here's a little practice. You could try these on your own if you want. And now I'm going to do them with you. So where it says graph x equals -1, we know that that means this line has every point that has an x coordinate of -1. So that's going to be all these points right in here where x equals -1. This line only has one number in its domain, and that number is -1, but the range is -infinity to +infinity. For f of x equals -2, this is equivalent to y equals -2, and so we know that this line contains every point whose y-coordinate is -2. So 0, -2, and any other point where the y-coordinate is -2, and that's going to form a horizontal line. So for this line, the domain extends forever to the left and forever to the right, so -infinity to +infinity. But the range is just this one y value, so the range is just the set containing -2. Okay, now we're going to talk a little bit about x-intercepts and y-intercepts. So we'll start with the x-intercepts. The x-intercept, as we have seen in a previous section, is the point where a line crosses the x-axis. So for this graph, that would be this point right here. I'll just call it a, 0. We know its y-coordinate is 0 because it's on the x-axis. So we'll call it a, 0. So a could be whatever number, but the y-coordinate is definitely 0. So again, because this point is on the x-axis, it will always have a y-coordinate of 0. To find the x-intercept from an equation, all we have to do is plug in 0 for y, because that's the one thing we know about the x-intercept is that its y value is 0. So to find the x-intercept, plug in 0 for y. Now for the y-intercept, that's the point where the line crosses the y-axis, and that would be this point right here. I'll call it 0, b. So because this point is on the y-axis, it will always have an x-coordinate of 0. So it'll be 0, whatever that number is. And therefore, to find the y-intercept, you'll plug in 0 for x. So do you see how it works? Whichever intercept you're looking for, you plug in 0 for the other variable. If you want to find the y-intercept, plug in 0 for x. If you want to find the x-intercept, plug in 0 for y. So here in example 7, it says find the x-intercept and the y-intercept of each equation. So we'll start with part A, and this says 6x plus 4y equals 12. Now we know that to find the x-intercept, we let y equal 0, or we could say we plug in 0 for the y. If we do that here, 4 times 0 will be 0. And so all that's left will be 6x equals 12. So basically, when you plug in 0 for y, the y term is going to disappear, and what's left will be the x term and the constant. And now to solve this, we divide both sides by 6, and we get x equals 2. So if x is 2 and y is 0, then the x-intercept is at 2, 0. Okay, now let's do the y-intercept. So we know that for the y-intercept, we plug in x equals 0. So back up here to the original equation. If we plug in x equals 0, this x term will disappear because 6 times 0 is 0. And then all that's left will be 4y equals 12. So now to solve this, divide both sides by 4, and that will give us y equals 3. And so now if the x is 0 and the y is 3, the y-intercept is at 0, 3. And now for part B, we have y equals 3x plus 8. So hey, notice that this one is in slope-intercept form. Now we weren't asked to find the slope, but if we had been, we could see that the slope would equal 3. Okay, let's start by finding the x-intercept. So we know that to find the x-intercept, we plug in 0 for y. When we do that here, the entire left side is just going to be 0. So we can't write nothing. Like over here, we didn't have to write the 0 because there was other stuff on the same side of the equal mark. But in this case, there is nothing else on the left side, so we do have to write 0 there. Okay, now I want to isolate the x. So I'll move the 8 to the left side of the equation. And so that'll give us -8 equals 3x, and then divide both sides by 3. And we can see that x equals -8/3. So if y was 0 and x is -8/3, then our x-intercept is at -8/3, 0. Don't let it bother you if one of your values is a fraction. That does happen sometimes. Now to find the y-intercept, we probably already know that the y-intercept is going to be 0, 8, But let's go through the steps anyway, just to make sure everything works the way we think it should. So we know that to find the y-intercept, we plug in 0 for x. And so if we do that, the x term is going to disappear, and we'll just have y equals 8. And so the y-intercept is at 0, 8. And that's exactly what we knew would happen from previous examples. And then here in part C, this one even looks a little different because it has no constant term. But that doesn't mean that we do anything different. We still will plug in y equals 0 to find the x-intercept and x equals 0 to find the y-intercept. Okay, so first, to find the x-intercept, we plug in 0 for y. That's going to give us 2 times 0 on the left side, which is just 0. Now to isolate x, divide both sides by 7, and x equals 0 divided by 7. We know that 0 in the top is 0. So x equals 0, and therefore our x-intercept is at 0, 0. Now to find the y-intercept, we plug in 0 for x. So if we plug in 0 for x, then 7 times 0 is 0, and now we divide both sides by 2 to isolate the y, and again we find that y equals 0. So this line, basically this line goes through the origin. So its x-intercept and its y-intercept are both at 0, 0, and that's no big deal. That can happen, so don't let it make you feel like you did something wrong or that you've made a mistake anywhere. Okay, now we're going to shift gears a little bit and talk about the standard form of a line. Standard form is just this way of writing the equation where the x term and the y term will both be on one side of the equal mark, and the constant will be on the other side of the equal mark. And there are a few other rules too. The a has to be positive, so you can't have an a negative. If a were negative, we'd have to multiply through by -1 to make it positive. Okay? The a, the b, and the c all have to be integers, so there won't be any fractions here. And also a, b, and c cannot have any common factors. In other words, they have to be mutually prime. So for example, if a, b, and c could all be divided by 2, we would want to divide through by 2. If a, b, and c could all be divided by 7, we would want to divide through by 7. We don't want to leave anything that will go into all three numbers. Now, to graph an equation in standard form, whenever you're asked to graph an equation of a line that's in standard form, you can put it in slope-intercept form and graph it the way we did in previous examples using the slope and the y-intercept. You can do that, but a lot of times there's an easier way. If you just need to graph the equation and you don't need to know the slope, in other words, they didn't ask you about the slope, you can avoid the solving steps if you graph using intercepts. So that's why we're practicing finding x and y intercepts. However, if the question asks you about the slope, it's usually easiest in that case just to go ahead and solve for y so that you can have the equation in slope-intercept form. Okay, so here we have example A, and this says find the intercepts and use them to graph the equation 2x plus 5y equals 10. State the domain and the range. Okay, now I could do the algebra steps that it would take to isolate the y, but in this case, it's so much easier to find the x-intercept and the y-intercept and not even bother with the slope. So I'll start by finding the x-intercept, and that means the y term is going to become 0. So to find the x-intercept, I'll have 2x equals 10, and then divide both sides by 2, and I'll have x equals 5. So the x-intercept is 5, 0, because remember we plugged in 0 for y, so we know the y-coordinate is 0. All right, now to find the y-intercept, we'll plug in 0 for x. So that means this x term is going to disappear. And for the y-intercept, then we'll have 5y equals 10, divide both sides by 5, and y equals 2. So the y-intercept is 0, 2. Okay, now we plot each of those points. So the x-intercept is on the x-axis, that's 5, 0, that's right here. The y-intercept is on the y-axis, that's 0, 2, that's right here. And there is the line. So if you want to graph using intercepts, that's how. And so now looking at the line, you can tell that the domain of this line will be negative infinity to positive infinity, and the range will also be negative infinity to positive infinity. Here's another one. So it says find the intercepts and use them to graph negative 4x plus 3y equals 12. Okay, to find the x-intercept, we let y equal 0. That means that y term disappears. And we have negative 4x equals 12. And when we solve for x, we get x equals negative 3. So the x-intercept is at negative 3, 0. And to find the y-intercept, we let x equal 0, so the x term disappears. And we get 3y equals 12, which means y equals 4, which means the y-intercept is at 0, 4. So now we plot both of those points. Negative 3, 0 is on the x-axis here, and 0, 4 is on the y-axis here, and there's our line, and the domain and range are both negative infinity to positive infinity. Now let's talk about how to graph a line in standard form where the constant on the right side is 0. So if a standard form equation has 0 on one side, then both the x-intercept and the y-intercept will be at 0, 0. We saw that in a previous example when we were finding x and y-intercepts. In this case, because the x and y-intercepts are both the same point, you need another piece of information to graph the line. So in this case, the easiest thing to do is put the equation in slope-intercept form and then graph using the slope and the y-intercept. So let's try an example together. So here you can see that we have 4x minus 5y equals 0. Because this is a standard form equation and the right side is 0, I already know that the y-intercept and the x-intercept both are going to be 0. So what I'm going to do is put this line in slope-intercept form. In other words, I'm going to isolate the y. So I'll start by moving the x term to the right side, and that will give us negative 5y equals negative 4x. And now I want to isolate the y, so I'll divide both sides by negative 5. That lets those negative 5's cancel out, and I get y equals negative 4x divided by negative 5. Now we know negative divided by negative is positive. 4/5 cannot be reduced, so we'll have 4/5 x. And there's no constant term, so that tells me something I already knew, which is the y-intercept is 0. So to graph this, I put a dot at the origin and then use the slope as rise over run. So rise 4, run 5, put a dot there, and connect the dots with a straight line. And that's how that works. Let's do one more like that. And this will be our last example together for this section. So we're going to graph 3y minus 4x equals 0. So this line is not exactly in standard form because we don't have the x term positive, but that's okay. We still handle it the same way. We can see that because the constant is 0, that the y-intercept is going to be 0 and the x-intercept is going to be 0. So the easiest thing to do here is get this line into slope-intercept form. So we'll just move this x term to the right side, and that will give us 3y equals 4x. Divide both sides by 3 to isolate the y, and now we have y equals 4/3 x. And there's no constant term. So that tells us, again, what we already knew, which is that the y-intercept has to be 0. So we put a dot right there at the origin, and then use the slope as rise over run. So rise 4, run 3, put a dot right there, and connect the two dots with a straight line, and that's it. Guys, graphing takes a little practice. A lot of students say that they have trouble with graphing. It's just because they haven't practiced enough. Anybody can graph. It's one of the easiest things in the world. You can do it. You just may have to practice and think about things a little longer, but once you catch on, you'll see that there is absolutely nothing to it. I don't want you to be intimidated by it or let it give you any hesitation. You just keep working on it and it will crack for you and you'll be able to do it. Okay, so keep practicing, Keep asking questions, and I'll see you in the next section. Hello again. Today we're going to go through section 2.5 of our college algebra book. This is equations of lines. We're going to talk about the point-slope formula. We're going to learn the slope-intercept form of a line. We're going to talk about equations of vertical and horizontal lines, and we're going to learn how to write the equation of a line that's parallel or perpendicular to a given line. So let's get started. We're going to start off talking about the point-slope form of the equation of a line. To use the point-slope form, you need to know the slope m of the line, and you need to know one point that the line is supposed to go through. We'll call that point x1, y1. So here's the formula. It says y minus y1, which is the y coordinate of the point we know, equals the slope times x minus x1, which is the x coordinate of the point we know. Now when we're all finished, we'll have numbers plugged in here for y1 and for m and for x1, but this x and this y will remain as variables. You need to memorize this formula, because even if you have a formula sheet that you can refer to when you need to use this formula, still, this is such a common formula that if you know it off the top of your head, you'll be able to work faster and better, and you probably will make fewer mistakes. You're going to use this formula every time a problem starts out by saying, write the equation of a line, blah, blah, blah. Whatever comes next, if it starts out by saying, write the equation of a line, this is the formula you need. So here we go with example 1. This says write the equation of a line through -4, 1 having slope -3, and I added solve for y. Your book does not say this, but really they should specify what form they want the answer to be in, because we do know point slope form, we know standard form, and we also know how to solve for y. So they need to specify how they want the answer. So I'm going to go ahead and tell you here that if it doesn't say what form to put the answer in, go ahead and solve for y. But I've specified it here. Okay, notice what they've given us. This is x1, y1, and this is m. So let's label the information that we have, and now let's write our formula. This is the point-slope formula. Y minus the y that we know equals m times x minus the x that we know. Plug in the numbers we have, so it'll say y minus 1 equals m times x minus x1, which is -4. Now, minus negative makes plus, and now we want to solve for y, so let's go ahead and distribute the -3. That's going to give us on the right side -3x minus 12. Now add 1 to both sides, and we will end up with y equals -3x minus 11. And if you remember from last time, we said that when the line is solved for y, the coefficient of the x term is the slope, and sure enough, our line was supposed to have slope -3, and it does. Now here is a homework problem that I wanted to go through with you. This one says write the equation of a line through -5, 4 having slope -3 halves. Because it starts out saying write the equation of a line, we know that we're going to need the point slope formula. So let's go ahead and identify the information that they gave us. The -5, 4 is our x1 and our y1, and the m is -3 halves. Now the point slope formula says y minus y1, so I have y minus 4, equals m, which is -3/2, times x minus x1. Now x1 is -5, so x minus -5 becomes x plus 5. Now remember, we want this solved for y. So probably the easiest thing to do is go ahead and distribute this fraction and just keep the fraction. I think if you try to multiply both sides by 2, you do eliminate the fraction, but you have to divide again by 2 in the end, and it just turns out to be a lot of work. It turns out to just kind of be the long way around the barn. It's easier at this point if we distribute the -3 halves which is going to give us negative 3/2 x minus 15 over 2, and add 4 to both sides. Now don't forget that this is a whole number and we're adding to a fraction, so we're going to need a common denominator. 4 becomes 8 over 2, so we'll write negative 3/2 x minus 15/2 plus 8 over 2. Now negative 15 plus 8 is negative 7. So we have negative 3/2 minus 7 over 2. Okay, here we go with example 2. This one says write the equation of a line through negative 3, 2 and 2, negative 4. Write the result in standard form ax plus by equals c. Now we know that whenever a problem starts off by saying write the equation of a line, what we need to do is think about using the point-slope formula. In order to use the point-slope formula, we need to know two things. We need to know the slope of the line and a point on the line. Here we don't actually have the slope given to us outright. They gave us 2 points on the line. What we need to do is use these 2 points to calculate the slope, and then use the slope that we calculate and either point we choose in the point-slope formula. At the end, we'll write the result in standard form, which means A will be positive, A, B, and C will all be integers, and A, B, and C should not all be divisible by the same number. Okay, let's write down what we have. We were given 2 points. I'll label them x1, y1 and x2, y2. And we also have our point-slope formula, and we also know we're going to need our slope formula. So let's go ahead and calculate slope. That would be y2 minus y1, which is negative 4 minus 2, over x2 minus x1, which is 2 minus negative 3. So we're going to end up with negative 6 over 5. Now we can use this slope with either point we choose. We'll get the same answer either way. I'm going to use the first point. So it's going to be y minus the y that I know equals m times x minus the x that I know. And we'll just totally disregard that other point. So y minus 2 equals our slope times x minus negative 3. All right, now go ahead and distribute the negative 6/5. That will give us negative 6/5 x minus 18 over 5. Now this time, because I need my answer to end up in standard form, it does make sense to multiply away these denominators. So let's multiply both sides by 5. That will give us 5y minus 10 equals, now when you distribute this 5, these 5's will cancel out and we'll have negative 6x and then minus 18. And now we want to get our x and y terms both on the left and our constants on the right. So let's add 6x to both sides. Of course, these do not combine because this is a y and this is not. So we're going to have 6x plus 5y. I've still got my minus 10 over here, and on the right side, negative 18. And now all we need to do is add 10 to both sides, and that gives us 6x plus 5y equals negative 8. This is standard form. Notice the x and the y terms are on the left, the constant is on the right. The x term has a positive coefficient, and the coefficients are all integers, and they cannot all be divided by the same number. So this is standard form. Here's a practice problem very similar to the last example we did together. You can try this on your own. Pause the video if you like, and if you've had a chance to do that, now we'll go through it together. It says write the equation of a line through these 2 points. Write the result in standard form. Okay, we know that whenever it says write the equation of a line, we're going to need the point-slope formula. And when you use the point-slope formula, you need to know one point and the slope of the line. Well, we know 2 points, and we do not yet know the slope. So let's go ahead and collect what we know. We have our 2 points. I'll go ahead and label them x1, y1 and x2, y2. We know we're going to need the point-slope formula, And because we don't yet know the slope, we know that we're going to need our slope formula. So let's first plug our 2 points into the slope formula. That's going to be y2 minus y1, which is 4 minus 3, over x2 minus x1, which is 3 minus negative 1. Of course, minus negative becomes plus. 4 minus 3 is 1, and in the denominator, 3 plus 1 is 4. So our slope is 1/4. Now let's take that slope and one of our points. Remember, you get to choose which point. I'm going to choose the second point for just no real reason. I just happen to choose it. Okay, y minus the y that we know equals m times x minus the x that you know. Okay, now since we want this in standard form, I know I'm eventually going to need to work this denominator out of the equation. So I'm going to go ahead and distribute this 1/4. 1/4 times x is 1/4 x, and 1/4 times 3 is 3/4. Okay, now I want to eliminate the denominators, so I'm going to multiply both sides by 4. On the left, that's going to give us 4y minus 16. On the right, when I distribute the 4, I'll have 4 over 4x, which is 1x, and 3 over 4 times 4, which is going to cancel the 4's and leave 3. Okay, now I know that I want the x and the y on the same side, but I need the x coefficient to be positive. So I could move the x over here to the left, but that would make the x coefficient negative. Instead, I'm going to move the 4y over to the right, and that's going to give us negative 16 on the left and x minus 4y minus 3 on the right. And now we will add 3 to both sides. And that's going to give us negative 13 on the left equals x minus 4y. Now it's in standard form, but it's just not arranged the way we usually like it. We like the x and the y on the same side, and we usually like them on the left, and we'll have the negative 13 on the right. And that's it. There's our standard form. Now here's example 3. It says find the slope and y-intercept of the line with the equation 4x plus 5y equals negative 10. Now, in order to see the slope and the y-intercept, we need to have the equation solved for y. When it's solved for y, that's called slope-intercept form. We have seen the line solved for y before, but we never called it slope-intercept form. We knew that the coefficient of the x term was the slope, but now we're going to find out that the constant term is the y-intercept. So again, slope-intercept form just means that the equation is solved for y. So let's go ahead and do that to this equation. We'll take 4x plus 5y equals negative 10. We're trying to solve for y, so we're going to move the 4x to the right side. That's going to give us 5y equals negative 4x minus 10. Now I'm going to divide each term by 5, and that's going to give us y equals negative 4/5 x minus 2. 10 over 5 makes 2. So now we can see that the slope is negative 4/5, and now we also know that the y-intercept is negative 2. So the slope is negative 4/5, and the y-intercept is negative 2. Here is a practice one for you from the homework, very similar. The instructions say find the slope and y-intercept of the line with the equation x plus 2y equals negative 4. Pause the video and try this one on your own, and then we'll go through it together. Okay, here we go. So to see the slope and the y-intercept, we will need to solve this equation for y. So we want to isolate the y. Let's first move the x to the right side. Of course, when you move a term to the other side of the equal mark, it changes sign. So now we have 2y equals negative x minus 4. And now to isolate the y, we'll divide both sides by 2. And now the 2's here are going to cancel out. The coefficient of the x we're going to write as negative 1 over 2. So negative 1/2, and then this term will simplify to negative 2. we end up with y equals negative 1/2 x minus 2. So the slope here is negative 1/2, and the y-intercept is negative 2. Now here is example 4. It says write an equation of a line through 1, 1 and 2, 4 in slope-intercept form, and graph the line using the slope-intercept form. Now we really don't need to know the equation of the line to graph it, because we do know 2 points on the line, and it would be possible just to plot the 2 points and draw the line. However, they've asked us to find the equation, and what we're going to do then is graph the equation and verify that these 2 points are in fact on the line like they're supposed to be. So first, let's decide what we want to do. We know that when it says write the equation of a line, we know we're going to need our point-slope formula. And we know that in order to use the point-slope formula, we need to know the slope and a point. Well, we know 2 points, and we don't yet know the slope. So let's take our 2 points, and let's label them x1, y1, and x2, y2, so we can use them in our slope formula. So the slope formula, remember, was y2 minus y1 over x2 minus x1. That's going to be 4 minus 1 over 2 minus 1, which is 3. And now in our point slope formula, I'm going to use this point. I'm going to use the point 1, 1. So y minus the y that we know equals m times x minus the x that we know. We'll go ahead and distribute that 3. And now we'll add 1 to both sides. That's going to give us y equals 3x minus 2. Now this is slope-intercept form, because I can see that the slope is 3, and I can see that the y-intercept is negative 2. So let's go ahead and plot the y-intercept here at negative 2. And now the slope is 3, so that means that from here I should rise 3, 1, 2, 3, run 1, so right here, and I'll put my second dot right here. And I could even, if I wanted a third point, do it again, rise 3 and run 1, just to get an idea of where the line goes. And now I'll connect those dots. That is our line based on our equation. But now let's verify that 1, 1 is on the line. See, here it is right here. And also 2, 4, right 2, and up 4 right here. And so those 2 points that they asked for are in fact on the line. Okay, now being able to write the equation of a line is a really important skill, and being able to graph a line from slope-intercept form is also a really important skill. So I definitely want to encourage you to pause the video here and try this one on your own. Try both parts. Make sure you can write the equation of the line, and make sure you can graph the line from slope-intercept form. Okay, now that you've tried it on your own, let's go through it together. If we're going to write the equation of a line, we're going to need the point-slope formula, which means we're going to need to know the slope of the line. So let's use these 2 points first to find slope. So the first point is x1, y1, and the second point is x2, y2. Now plugging into our slope formula, we'll have 2 minus 3 over negative 1 minus 2. 2 minus 3 is negative 1. And negative 1 minus 2 is negative 3. Negative 1 over negative 3 is positive 1/3. Now, using our slope of 1/3 and using this point 2, 3, I'm going to use the point slope formula. Keep in mind we could have just as easily used this point. It wouldn't make any difference. I just had to choose one, and I happened to choose this one. So y minus 3, which is the y that we know, equals m times x minus 2, which is the x that we know. And now since we want the line in slope-intercept form, I'm going to go ahead and distribute the 1/3. And now I'm going to add 3 to both sides. And I'll need to add negative 2/3 plus 3. Now 3 is, when you get a common denominator, is 9/3. So negative 2/3 plus 9/3 is 7/3. So now we have a slope of 1/3 and a y-intercept of 7/3. Now I know that since the y-intercept is a fraction, you may be feeling like something went wrong, but it didn't. So what we're going to need to do is figure out where on the y-axis we can find 7/3, and that's where the mixed number form can help us. 7/3 is equivalent to 2 and 1/3. You know, 3 goes into 7 twice with 1 left over, so 7/3 is 2 and 1/3. I'm going to put a dot here between 2 and 3, a little closer to 2. So there's my dot. That's 7/3 or 2 and 1/3. Okay, now for the slope, remember is rise over run. So from that point I will rise 1 and run 3. So from here I will rise 1, which is going to put me about here, and run 3. 1, 2, 3. Our second dot will go about right here. And now we will connect the dots. That is the graph of this equation. And now let's verify that our two given points are on the line. 2, 3 would be from the origin right 2 and up 3. And -1, 2 would be from the origin left 1 and up 2. So left 1 and up 2. About there. So it looks pretty good, especially for a hand-drawn graph. You could do even better on graph paper, but there it is. Now in example 5, we're considering the same type of question, but we're coming at it from the opposite direction. In the past, we have had an equation and we've been asked to graph it. This time we have the graph and we're going to be asked to write the equation. But first they're going to ask us to find the slope and the y-intercept and the x-intercept by looking at the graph. So first let's remember that slope is rise over run, and let's use these 2 points that are given to us to calculate rise over run. Now I usually start with the left point, which in this case also happens to be the higher point. And first I think about rise. How far is it up or down to the next point? Well, it seems to be down 1. And so the rise is actually -1. And now the run is how far horizontally I have to go to get to this second point. So from here I have to go 1, 2, 3. And so the run is +3. And our slope ends up being -1 over 3, or we could say -1/3. Now we also, from these 2 points, we can get the x-intercept is -3 and the y-intercept is -1. Now to write the equation of the line, since we know the slope and we know the y-intercept, all we have to do is plug those numbers into our slope-intercept form. This is one exception to the rule that we always will need the point-slope formula. If we know the slope and the y-intercept, we actually don't need the point-slope formula. We just can plug in these known numbers. So it's going to be y equals mx, so -1/3 x, plus b, which is -1. So -1/3 x minus 1. And there is the slope-intercept form of the line. As always, here is the practice problem for you to try on your own. So pause the video and try this one by yourself. If you've had a chance to do that, now let's go through it together. So first it says find slope, y-intercept, and x-intercept. Remember, slope is rise over run. So I'm just going to choose 2 points on the line. I chose these 2 that have nice whole number values that we can use. Okay, so now I need rise over run. From this point to this one, the rise is down 2. So rise is -2. And from here to here, the run is +1. So our slope ends up being -2 over 1, which is -2. Now the y-intercept is where the line crosses the y-axis, so that's going to be +1. And the x-intercept is where the line crosses the x-axis. That, I'm guessing, is about 1/2. It just looks about 1/2. We can be sure later when we have the equation of the line, but for now let's just say it's about 1/2. And now to write the equation that defines the line, all we need is the slope and the y-intercept. So remember, it's y equals mx plus b, where m is the slope and b is the y-intercept. So this is going to be y equals negative 2x plus 1. Now if you wanted to be sure about your x-intercept, what you could do is plug in y equals 0 and solve this for x. And you can probably see that if you put a 0 here, you could move this 1 to the left side and divide both sides by negative 2, and you would end up with exactly positive 1/2. So our guess at our x-intercept was a good one. Now we're going to talk about equations of vertical and horizontal lines. Remember that in a vertical line, all the points have the same x value. Here's a vertical line. Notice that its slope is undefined, and also notice that it's not a function. And also notice that we don't really need to calculate anything. Every x value is the same. So all we need for this line's equation is x equals whatever that x value is. In this case, it would be x equals 3. And now let's talk about a horizontal line. In a horizontal line, all the points have the same y value. So the equation of a horizontal line is going to be y equals whatever that y value is. In this case, y equals negative 2. And remember, this is a function, and it's just a line whose slope is 0. So you have no x term because the coefficient of your x term in this case would be 0. Okay, let's give you a chance to write the equation of a couple of lines here. So the first one says write the equation of a vertical line that goes through 2, 7. I think it's helpful always to have a little sketch to look at. And so I'm going to draw myself a coordinate system and plot the point 2, 7 and draw a vertical line through it. And that just helps me see that what all these points have in common is they all have the same x value. And so now I know that I can write the equation of this line as x equals 2. And let's write the equation of a horizontal line that goes through negative 7, 4. Okay, so again, I want a sketch. Negative 7, 4 would be about here, and a horizontal line would go this way. And when I look at that horizontal line, I can see that all of these points have the same y value. So now I know that I can write y equals 4. The last thing we need to do in this section is talk about parallel and perpendicular lines. Our goal is to be able to write the equation of a line that's parallel to another line or perpendicular to another line. So we need to know something about how the slopes of parallel lines and the slopes of perpendicular lines relate. Two non-vertical lines are parallel if they have the same slope. You can see here I have two parallel lines. Parallel means they're never going to cross. So two lines can only be parallel if they have the same slope. Otherwise, if they didn't have the same slope, at some point they would have to cross. So parallel lines have the same slope. Two non-vertical lines are perpendicular if they have slopes that are opposite reciprocals. So remember that slope is rise over run. So this line, this blue one, has a slope of c over d. If we rotate that to the perpendicular position, what used to be the rise becomes the run, and it's backwards. And what used to be the run becomes the rise. So this blue line has a slope of c over d, but this red line has a slope of negative d over c. So you see that they are opposites in sign. One's positive and one's negative, but they also are reciprocals. So two perpendicular lines will have slopes that are opposite reciprocals. Now in example 6, we're going to write the equation in both slope-intercept form and standard form of a line that passes through the point 3, 5, and we want our new line to be parallel to 2x plus 5y equals 4. Now, in order to write the equation of a line, you know that we need to know a point on the line, which is 3, 5, and we also need to know that line's slope. Well, they did not give us the slope, but they did ask us to make the line parallel to this line. And we know that parallel lines have the same slope. So if we could find this line's slope, we would know the slope of our new line. All we need to do is solve this equation for y. So let's move the 2x to the right side of the equation, and let's divide by 5. Now we can see that y equals negative 2/5 x plus 4/5. So the slope of this line is negative 2/5. Therefore, the slope of our new line will also need to be negative 2/5. And remember that we want our new line to go through the point 3,5. So now we'll use the point slope formula to generate the equation of this line. So we'll say y minus the y that we know equals m times x minus the x that we know, which is 3. And first let's get this equation in slope-intercept form. So we will distribute the negative 2/5. Now negative 2 times negative 3 is positive 6, so this term ends up as positive 6/5. Now we will add 5 to both sides. Now remember, you can't just add 6 plus 5 because we need a common denominator. So 5 becomes 25 over 5. And now 6/5 plus 25/5 is 31/5. So we have y equals negative 2/5 x plus 31/5. The slope here is negative 2/5 as it should be, and the y-intercept is 31/5, which is the same as 6 and 1/5 if we needed to graph it. Now we want to put this equation in standard form, so we'll need to eliminate these denominators. Let's multiply both sides of that equation by 5. And now we'll have 5y equals, on the right side, these 5's will cancel and we'll have negative 2x, and these 5's will cancel and we'll have plus 31. So 5y equals negative 2x plus 31. Now to get to standard form, all we have to do is move the x term to the left side so it can be positive. Now we notice that we have a positive x term. 2 and 5 and 31 are mutually prime. That is, there's nothing that goes into all three, and they're all integers. So this is standard form. Now in part B of example 6, we want to write the equation in slope-intercept form and standard form of the line that passes through 3,5, and this time is perpendicular to 2x plus 5y equals 4. So we know that in order for a line to be perpendicular to another line, their slopes have to be opposite reciprocals. Now you'll remember in part A we just found the slope of this line, and we found out that that line's slope was negative 2/5. So the slope of our new perpendicular line will need to be positive 5 over 2. We change the sign and we flip the number over to get the opposite reciprocal. Now, our new line needs to also still go through the point 3,5, and so we will use the point slope formula with this point and our new slope. We'll say y minus the y that we know equals our new slope times x minus the x that we know. Since they asked us to get the equation of the line in slope-intercept form and standard form, let's go ahead and get the slope-intercept form first because we're so close. Let's distribute the 5 halves. 5 halves times x will be 5 halves x, and 5 halves times negative 3 will be negative 15 halves. Okay, now if we just add 5 to both sides, we'll have to get a common denominator here. 5 is 10 halves. Just multiply top and bottom by 2. And so we'll have 5 halves x minus 15 halves plus 10 halves. Negative 15 plus 10 is negative 5. So we have 5 halves x minus 5 halves. Now that is our slope-intercept form. And now let's take this form and transform it into standard form. So we'll need to eliminate these denominators. We will multiply everything by 2. And that's going to let these 2's cancel and these 2's cancel. We'll have 2y equals 5x minus 5. And now all we need to do is get the x and the y on the same side, and remember we need the x to be positive. So what I've decided to do, since x is already positive, I've decided to bring the 2y term over to the right, and that's going to give us 0 on the left equals 5x minus 2y minus 5. And now, of course, I need to bring the 5 over to the left to make it positive. But usually we write the x and the y on the left and the constant on the right. So remember, I'm bringing this negative 5 to the other side and it will be positive, but now when I write it, I'm writing 5x minus 2y equals positive 5. And that is our standard form. Here are a couple of practice ones from the homework, so feel free to pause the video and try these next two on your own. I'm just going to walk through both of them with you. Here we go. So it says write the equation in both slope-intercept and standard form of a line that passes through negative 1, 4 parallel to x plus 3y equals 5. So we'll need our new line to have the same slope as x plus 3y equals 5. Let's solve this equation for y so we can see what that slope is. So I'm going to move the x term to the right side. It becomes negative, and I'm going to divide each term by 3. So the slope of this line was negative 1/3. Therefore, I need my new line to have a slope of negative 1/3. So now using this point, negative 1, 4, we're going to use our point slope formula to say y minus the y that we know equals m times x minus the x that we know, but minus negative 1 will be written as plus 1. Okay, now we're very close to slope-intercept form here, so let's go ahead and distribute the negative 1/3. And now let's add 4 to both sides. And you know, when you add a fraction to a whole number, you need a common denominator. So 4 becomes 12/3. All you need to do is multiply this 4 by 3/3 to see that. And now negative 1/3 plus 12/3 gives us 11/3. So our final slope-intercept form of this line is y equals negative 1/3 x plus 11/3. Now let's go ahead and transform it into standard form. So we'll need to eliminate these denominators. I'll multiply everything on both sides by 3. And now we're going to have 3y. These 3's will cancel and these 3's will cancel. And on the right side, that will give us negative 1x plus 11. Now this is almost standard form. All I need to do is bring this negative x to the left side so it can be positive, and so that the x and the y can be together on the same side. We end up with x plus 3y equals 11, and that is the standard form of this line. Now let's go ahead and look at 47. You might want to pause and try it on your own first if you haven't already. So this time we have a different line. We have 3x plus 5y equals 1. So if we want to be perpendicular to this line, we'll need to use the opposite reciprocal slope. Let's solve that line for y so that we can see what its slope is. And when I solve for y, I see that the line they gave us has a slope of negative 3/5. That means the slope of my new line needs to be positive 5/3. Change the sign and flip the number over. Okay, now I'll be using the point slope formula with the point that they gave us and my new slope of 5/3. So y minus the y that we know equals m times x minus the x that we know. Let's go ahead and distribute the 5/3, and let's go ahead and add 6 to both sides. Now when I add 6 to both sides, because I'm adding to something that has a denominator of 3, I will want to change the 6 to thirds. So multiply this 6 by 3/3, and we see that 6 is equivalent to 18/3. All right, now negative 5/3 plus 18/3 adds up to 13/3. And here is our slope-intercept form. And now we'll transform that into standard form. So what we're going to do is multiply both sides of the equation by 3. That will let these 3's cancel out, giving us integer coefficients all the way around. And we'll have 3y equals 5x plus 13. Now to get this to standard form, I'll want this y term over here with my x, and my x is already positive on the right, so I don't want to make it negative, so I'm going to leave it there, and I'm going to bring the 3y over to the right. And now, in order to get the constant on the left side, I'm going to bring 13 to the left side. That will make it negative. And now, just to make it look right, I'm going to put the x and the y on the left and put the constant on the right. So we'll have 5x minus 3y equals negative 13, and that is our standard form.